fire and water are all very much intertwined. And often people think of obviously water as suppressing fire. One of the key things from a bushfire perspective is then the impacts on the water system, both during the fires and then after the fires. And what does that actually mean for the aquatic life in Australia? So, John, Libby, and Rachel, can you give us some insights of what has been discovered in that regard?
Yeah, look, the natural world is marvelously interconnected, and fires in a catchment will have impacts upon the water system within that catchment as well, that in some cases tens of kilometres downstream. So we know from previous studies of wildfires that burnt areas will lose between 20 and 50 tonnes per hectare of soil post-fire, because when the rains subsequent to the fires wash off the deposition of ash and the like. And that ends up in the water system with sedimentation and contaminants to the water system. So these impacts may be long-lasting, and they may be really detrimental to aquatic species, to fish, to platypus, to aquatic invertebrates, and to the sort of whole health of those water systems on which much of our life depends. So those systems, the aquatic systems, are really important as ecological pivots to the landscape, as cultural markers of the landscape, important cultural sites. And they're really important economically as well. So we know that many of the threatened aquatic species, particularly fish, many of which are really localized, were really severely affected by these fires, particularly the sedimentation and the contaminants. Metals like arsenic became, because of the ash, became really highly concentrated in the water systems. And in some cases, we've had reports of jet black water flowing down the creeks, which has killed hundreds to thousands of fish and all sorts of, made really rich, diverse water systems into almost deserted, malfunctioning systems. And that can take really many years to recover from.
I'll just jump in and say one of our projects actually reviewed the scale of the impacts in southeastern Australia and documented 26 sites in the southeast where there were documented fish kills in the context of the fires. Many sites had hundreds of fish deaths, in some cases thousands. So, for example, one site at Jingellic on the Murray River, the maximum turbidity, so that effectively the density of ash and sediment in the water was more than 100 times what the maximum turbidity normally is in that system, and that system did see the dissolved oxygen in the water dropping to zero. So thousands of fish were documented as being killed there. So that was one of the worst impacted sites, but there were many other sites with similar problems documented. So, another piece of research that we did looked at the nutrient, the impacts of these runoff and ash and nutrient in the waterways on fish, and looking at non-threatened fish as sort of proxies for their threatened cousins to understand those impacts. And indeed, there were impacts, particularly certainly at high levels of ash and sediment, and with oxygen dropping to 15% of normal, you start to see impacts on the fish species' ability to perform, their ability to move, their ability to function in their waterways. And of course, that means that has this long-term detrimental impact on individuals, even where it doesn't lead to those fish kills. Invertebrates as well, particularly the embryos and juveniles of many of the invertebrates we looked at were heavily impacted by the nutrients, and the ash runoff. So that sort of reconstruction of the fire context tells us a lot about what the effect on individual species, including on the threatened species that are the cousins of the species we looked at, is likely to have been.
And Rachel, it's probably worth, sorry, Libby. Rachel, it's probably worth remarking that there was some really heroic conservation efforts that were undertaken for threatened fish. Many of Australia's threatened fish species are really localised. They only occur in the upper headwaters of small creek systems, largely because of the impacts of introduced fish species, trout mostly. And so a whole range of fish biologists and conservationists and community groups went to those areas immediately after the fires and extracted the fish before the rains subsequent to the fires forced the sedimentation into the system. And because of those heroic efforts, many of these threatened species were actually conserved, which would otherwise almost certainly would have been lost because of these fires. Sorry, Libby.
That's okay. I think on that point, it's it's important to note that some of these emergency rescue efforts are repeated efforts. So that this is not the first time that scientists have gone in to rescue, say, some of those galaxid species. And so we really again have to think about this as a problem into the future. These events are not going away, and if anything, they're going to increase in frequency. So we're really up against some very hard conversations, I think, about, well, what do we do about these species? Do we keep going in and rescuing them, for instance? So the other thing I wanted to say in response to those earlier points is that we need to think about the variability in terms of the types of impact that these fires are having on waterways. So we can think about turbidity and temperature and nutrients and so on. And we also need to think about how different species respond to these events as well, because it's not the same, and I think some of the really severe impacts, that was, great, John and Rachel pointing out some of these really serious kind of localized impacts, but yeah, it's really variable across the landscape. And some of the conversations we've been having as part of these as part of the research is with these experts, and understanding that species respond differently. Species have different traits that mean that they they survive or are impacted by fire really differently. So yeah.
And I think I'll just add to that. I think one of the things to think about is, this is also a human systems problem. And so, one of the big things that can be asked about this is what kind of response we can do, both in the aftermath, preparing, but also in the aftermath. So John talked about the heroic efforts of fish rescue. A lot of those were done on the smell of an oily rag. One of the things that our research did was actually interview many of the people involved in those early recovery efforts for waterways. And one of the common themes that came out of that was that even where rescue efforts were identified as priority actions, the funding for those was slow to emerge, and not so much in New South Wales, where there was emergency funding already set aside because of the drought, but in other states where that hadn't happened to have been the case. People really did, it was heroic in the sense that people actually just had to go and find ways to do it. So one of the recommendations emerging from that report is the need for emergency funding to flow really quickly and to be available, but also the need for more coordination of efforts, because there was a lot of, it was very, very dependent on the individual commitment of experts and people connected to certain systems to go out and make those efforts successful.
Yeah, and I think, Rachel, like on that note, there's funding for emergency efforts, and then we think about funding for recovery and yeah, as well. And so I think one of the big issues that was noted in terms of were impacts to waterways and erosion, and it was a serious threat that was identified across the regions that were impacted by fire. But it's expensive, like it's really expensive to do something about. And we think about, areas of private land that were impacted and areas of public land that were impacted. This is a huge problem, and it's something, when we think about repeated events, this is only going to get it's only going to be more of a serious issue. So thinking about, okay, well, how do we invest in recovery of these waterway systems is kind of critical, because we have to think about this system as a whole. It's not just impacts on the waterway, it's impacts on our terrestrial systems and on people as well.
Yeah.
And you've got to counterpoint that investment in repairing the damage that's been done to the waterways after fires, or preventative measures to reduce the likelihood of such things happening in the future, with the extraordinary economic and social value of those waterway systems anyway. So it's a cost, but it's an investment in a more economic return, I think, as well.
Yeah.
I think the other thing to add is just, you know, the scale of the fires meant that the impact on the soils was qualitatively different in many areas to what we would normally see for a lower severity fire. So what we've seen in many of the fire affected areas is a 1-2 fire and flood kind of event. So they build on each other. So where the soils are heavily impacted and compacted, the risk of flood is higher. And so in many regions, you see this this combined effect. And so we really need to understand more about what that combined impact is going to be in future. And really prepare our ecosystems, you know, and that interaction between really understand that interaction between the terrestrial and the freshwater and even the ocean contexts in order to build that preparedness better in future.
And there's one other point, if I may, and that is that the rainfall events following fires not only result in pollution to the river systems, but they also deplete the seed store in the forests or other vegetation types as well, and reduce the nutrient capability in those forests as well. So they degrade the whole systems. So it's a really whole of ecosystem problem.
And look, and thanks for that conversation. I think it just shows the amazing complexity and that it's not just one aspect and that we've only, I suppose, to a degree, scratched the surface of a level of knowledge, particularly as to how species will react, the different impacts, what are the longer term impacts on our waterways, both, you know, freshwater and also that flow into the marine environment. So thank you very much for that conversation. As I said, there'll be more information available for those that you would like to find out more.